Hi everyone, welcome to Numeric Learning. In today's video, let's continue solving the exemplar exercise of the chapter Polynomials, and this is exercise 2.2. We covered 2.1 in the previous video. Please do check out if you haven't. Let's get started with today's exercise question. Question number 1. Can the quadratic polynomial x square plus kx plus k have equal zeros for some odd integer k greater than 1 is the question. So whenever you have got equal roots, right, whenever for any polynomial you have got equal zeros or equal roots, the thing that you have to remember is that the discriminant is always 0. D is always 0. So what is the value for, how do you calculate D? Discriminant b square minus 4ac. Let me write here discriminant is equal to 0. And what is b here? So from the given polynomial, you have your a is 1, the coefficient of x square, your b, coefficient of x is k, and your c is also k. So what is b square? K square minus 4 into a is 1, c is k, equal to 0. So k square minus 4k equal to 0. Take k common out, so you'll be getting k minus 4 equal to 0. So either k is equal to 0 or k minus 4 equal to 0, which means k is equal to 4. What are they asking? Can this quadratic polynomial have equal zeros for some odd integer k greater than 0? So one of it is k equal to 0, but for a value which is k greater than 0, k is an even integer. It's not an odd integer. So this particular question would say no. Right? It cannot have. So the answer is no. This quadratic polynomial cannot have an odd integer. For when it has equal roots, it cannot have, k cannot be a number greater than 1 and an odd integer. So the answer is no. Right? You have to write it. No, the given quadratic polynomial cannot have an odd integer for equal roots. So that should be your answer. I hope you understood, because you are getting an even integer for k greater than 1. This is even. Let's move on to the second question. You will be given, say there are 4 questions under this. Are the following statements true or false? Justify your answer. The first question is, if the zeros of a quadratic polynomial ax square plus bx plus c, can the zeros are both, if the zeros are both positive, then a, b and c all have the same sign, right? Now let us take with an example. So what is given? That if the zeros are both positive, right? So let the zeros, let's take any 2 positive integers. Okay, let the zeros be, say 3 and 5 respectively. That means let alpha be 3 and your beta be 5. How will you write a quadratic polynomial if you know the zeros? Your k multiplied by x square minus the sum of zeros plus p. So k multiplied by x square minus, what will be the sum? 3 plus 5. 8x plus 3 into 5, which is 15. Okay, so for k equal to 1, when you have your k is equal to 1, the quadratic polynomial is x square minus 8x plus 15. Here what is a? A is 1, right? A is 1, which is a is greater than 0. What about b here? B is minus 8. So b is less than 0 or b is negative. And what about c? C is a positive value. So c is also greater than 0. However, not a, b and c. All the 3 are not of the same sign. B is of a negative sign. Right? A, B and C are not of the same sign. So what is the statement? The statement says if the zeros of the given quadratic polynomial are both positive, then A, B, C all have the same sign. No, it is not, right? A, B and C do not have the same sign. So, is it true or false? It is false. Okay. Let's move on to the second question. If the graph of a polynomial intersects the x-axis at only one point, it cannot be a quadratic polynomial. So, suppose, okay, you have got, there are two same zeros, okay, you have a graph and both the zeros, okay, there are two zeros, alpha and beta, are both equal. So, if two zeros, that is alpha and beta, are both the same points, right, then both would be the 2 points, the two intersecting points will be coinciding and they'll become a single point, right? So, whenever the two zeros of the quadratic polynomial are equal, then both the points will be coinciding and it will become one point. Am I right? So, here what they say is it cannot be a quadratic polynomial. But so this is nothing but it's false. Why is it false? Because there is a possibility that both the zeros alpha and beta could be same or could be equal. In that case, both will be coinciding and becoming a single point. So it is possible. Okay. Next one. If the graph of a graph of a polynomial intersects the x-axis at exactly 2 points, it need not be a quadratic polynomial. Is it true or false? See, whenever the graph of a polynomial, it intersects the 2 points, it intersects the x-axis at exactly 2 points, it need not be a quadratic polynomial. So it is true. It may be a quadratic polynomial, it may not be a quadratic polynomial. The answer is true. Okay, why? Because so a polynomial of degree more than 2 is also possible, which intersects the x-axis at exactly 2 points. Suppose if it has got say 2 real roots and the other roots are all imaginary roots, then there is a possibility that it may be a quadratic polynomial, it need not be also a quadratic polynomial. So, if the graph intersects the x-axis at exactly 2 points, it may or may not be a quadratic. Now, suppose here if you have a graph like this graph also intersects the x-axis at exactly 2 points. Do you say this is a, can you say this is a quadratic polynomial? No, you cannot say. Okay, so it may be, it may not be a quadratic polynomial. So the answer is true because it says it need not be a quadratic polynomial. So it is correct. The statement is true. So I hope you are getting it. Let's move on to the next question. The only value of k for which the quadratic polynomial kx square plus x plus k has equal roots is 1 by 2. Let's write the given polynomial. P of x is nothing but kx square plus x plus k. What is a here? A is k, b is 1 and c is also k. As I told you, whenever you are dealing with the polynomial with equal roots, your discriminant is 0, which means b square minus 4ac is equal to 0. What is b square? 1 square minus 4 into a is nothing but k, c is also k, equal to 0, right? So 1 minus 4k square equal to 0, or 4k square will go to the other end, 4k square equal to 1, or k square is nothing but 1 by 4, or I can write k is equal to plus or minus root of 1 by 4, or nothing but plus or minus 1 by 2. So k can be two values, right? It can either be plus 1 by 2 or it can be minus 1 by 2. Okay. So for both these values of k, that is 1 by 2 and minus 1 by 2, the given quadratic polynomial has got equal zeros. So this statement that it says that the only value of k for which the quadratic polynomial has equal roots is only 1 by 2. No, it is false. This statement is false because it is not just plus 1 by 2. You can also have minus 1 by 2, k as minus 1 by 2, for which the polynomial can have equal zeros or equal roots. Okay, so this statement is false. I hope you understood. And these are the only questions which are there in your exercise 2.2. And there's one more announcement that I would like to make, that every Sunday 6 p.m. please do join me on a live session wherein we will be solving MCQ questions, all multiple choice questions from previous year's questions. And this week, for the coming week, we'll be solving questions from the chapter Polynomials. So do keep your reminders and definitely do join. It will definitely be an interactive session and you will definitely learn a lot. The time is 6 to 7 p.m. And this video, if you like it, please do consider subscribing, do share it with your friends, and see you all in the next video, that is exercise 2.3. Till then, take care and happy learning. Thank you.